Hello, my name is Meredith Renaud, and this is my Physics 2212 lab report for Lab 1 charged tapes. In this lab report, I will be discussing how to determine the sign of charge of the tape, the charge of the tape, and how to calculate the minimum distance for the tape strip to float. I will also be discussing Coulomb's law, how to calculate the gravitational force, and the conservation of charges, which are the primary physics principles included in this lab. My results include that the charge of the tape was positive, and in order for the tape to float, the gravitational force must be equal to the electric force. During this lab, I noticed that the tape was attracted to my hand and my textbook after it was released from the desk. Once it was put near the negatively charged plastic pen, it was also attracted to it, and so I determined that the charge of the U-tape was positive, since like charges repel and opposite charges attract. To determine the magnitude of the charge, I first had to find the gravitational force. To find the gravitational force, I multiplied the mass by the gravitational constant g. Since there was no momentum, the net force was 0, which meant that the gravitational force and the electric force had to be equal, since those were the only y component forces acting on the tape. Therefore, I knew that the electric force, was equal to 1 over 4 pi epsilon naught times the charge squared over the distance squared, the distance between tape A and tape B. And when you manipulate that formula, I got that the charge was equal to the square root of the force electric times 1 over 4 pi epsilon naught times the distance squared. If a charged plastic pen was placed near a U-tape that was positively charged, those two items would be attracted to one another because the plastic pen would be negatively charged. As you can see in the diagram to the right, opposite charges are attracted to one another. However, if the U-tape was negative, then those charges would repel because like charges repel. If the neutral U-tape would interact with a charged plastic pen, then the neutral U-tape would be attracted to the charged pin as well, because the electrons would move to one side and the protons to the other, pulling it closer to the charged pin. After rubbing the plastic pen onto my pants leg, I realized that the U-tape was positive, and that's how I came to the conclusion from the last slide. When the momentum of a tape B is not changing, the net force is 0, which means the net y component of the force is 0 as well. And the objects in the surrounding that exert these vertical forces are the earth that exert a gravitational force and the tape A that exerts an electric force. Here is a visual representation of the equilibrium of the vertical forces on tape B. Pointing up is the electric force and pointing down is the gravitational force, but the magnitude of both of these forces are equal, which means that the F net is equal to 0. In order to determine the gravitational force, you need to measure the mass of the tape, and in this case, the mass of tape B was 0.0002 kilograms. I had to code under the assumptions that are listed at the bottom of the screen. I started out with two spheres, the blue representing tape B and the red representing tape A. The two arrows represent the two vertical forces that are on tape B. The yellow, the gravitational, and the purple, the electric. These forces are equal in magnitude due to the fact that the net force was 0, which means that these forces would be equal. I'll take this time to go over my specific data since the code itself is pretty self-explanatory. The length of my tape was 0.2 meters and the mass was 0.0002 kilograms. The distance between the two tapes after floating was 0.0145 meters. The magnitude of the gravitational force on floating tape was mass times the gravitational constant, which was 0.00196, which means that the magnitude of electric force was that same value of 0.00196. The tape's charge was 6.53 e to the negative 9, and the number of electrons on the tape was 4.1 e to the 10. Additional questions for this lab included, what if electrons had positive charge and protons had negative charge? While the two would switch, the reactions with one another would not change, so the observations would not change. Like charges would still repel and opposite charges would still attract. And why is it important to handle the charged tapes as little as possible? It's because of the amount of water on the surface of your skin, which can cause polarization and the neutralization of the tape. When the tape comes into contact with your hand or other objects, it loses electrons and therefore loses charge, which affects the lab. Thank you for watching my lab report 1.